Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, I am going to work through 20 different examples of graphing linear equations in slope-intercept form. Now, not all of them are in slope-intercept form. You can see that I have a couple of equations, or I don't actually have equations at all. I'm actually just giving you the slope as well as the y-intercept. So I'll kind of cover those examples as well. But my really main point is I wanted to understand how to graph using slope-intercept form. But to do that, we need to kind of understand what exactly is slope-intercept form and what exactly is the process for graphing. So first of all, we are going to be graphing on what we call an XY plane. All right, and it's a number line, a horizontal number line, and a vertical number line. So x is going to represent the horizontal distance, and y is going to represent this vertical distance. Now, typically, we're going to have 0 where they intersect is going to be what we call the origin, which is 0, 0 for both those. So x is going to represent the distance away from 0, right, in the positive or negative direction. And we can do the same thing for y in that positive as well as negative direction. So when we have a point on the graph, that is called a coordinate point because it has a x as well as a y coordinate. Now this is going to be important because when we look into slope-intercept form, we have this y equals mx plus b. So the x and the y represent those coordinate points. Now again, when we have a line, however we're going to graph, all these different lines we're going to graph, there's infinite many points that make up a line. So therefore, the x and y in this equation represent the infinite many points that make up a given line. Whereas m is going to represent the slope. And basically, that's going to be the change between each of those points from a horizontal as well as vertical change. So a lot of times we call that the rise over the run because we're not just looking at the change horizontally or the change vertically of those points, but we're looking at that ratio of the comparison from the vertical change over the horizontal change. And then the last point so that's going to be our slope. And the last thing is going to be b, which is going to be our y-intercept. And that's going to be basically the point where the graph is going to change, where the graph is going to cross the y-axis. Why am I doing that? So let's call that the slope, the y-intercept. Okay, so for instance, let's just say we had a graph here. Okay, so you can see here, that is going to be your y-intercept. And if we were going to look at this change here of the, let's do it here. That'd be the y-intercept. Then when we're looking at the slope, that's going to be the change in the rise, or that vertical change of the graph over the run. Okay. So we can say slope m equals the change in the vertical change over the horizontal change. A lot of times we call that the rise over the run. All right. So basically the process that we're going to go about this, it doesn't matter if I give you the y-intercept and the slope or if I give you an equation. The first thing I think is important is to understand that, the y-intercept and to plot that point. Then what we're going to do is we're going to use the slope to find another point. Now remember, when we're graphing a line, we only need to figure out we need to figure out 2 points. So if we have the y-intercept, we just need to figure out one other point. And it doesn't matter if we go in one direction, like up and over, or if we go down and over in the other direction, right? It's going to produce a line. So we can go in either one of those directions. So we'll kind of talk about this as far as when the slope is positive and negatives and how we go about that. But for the first part, let's just kind of do this first question here. And the first question I have the y-intercept is 0, 2. So what I'm going to do here is, again, that y-intercept, if I was going to graph this as a coordinate point, you can see why this is the y-intercept because the x-coordinate is 0. So I'm not going anywhere on this x-axis, but the y-coordinate is 2. So we can go up 1, 2. All right, so you can see that's where the y-axis is. Now, the next thing is the slope. Now, remember, slope is always a comparison, right? It's the comparison of the rise of the run, or that vertical change over the horizontal change between any 2 points. So if you have a whole number, make sure you write your slope as a ratio or as a fraction. So this is going to be 3 over 1, meaning we have a vertical change of 3 compared to a horizontal change of 1. Now, that could be a positive vertical change over a positive horizontal change, right? And that would produce our line. Or you can also think about that as a negative vertical change, -1, 2, 3, and a negative horizontal change. And if you see, what happens is that produces the exact same graph, right? If here's my point, if I go up 3 and over 1, that's going to produce the same point if I go down 3, -1. right? Because if you think about this, 3 over 1 is equal to -3 over -1. So there really is no right answer as far as which way to go or which way to graph. Typically, we always like to go to that positive and right direction, but sometimes it's just going to be easier actually to go in the, to the left or in the negative direction, just kind of based on what information you have. So either way, I'm just going to connect these. I have 3 points. I only need to know 2, but therefore we can go ahead and sketch the graph of the slope, the graph, and yeah, let's go and see. As the graph is going, as we read the graph from left to right, you can see it's going up. Therefore, we're going to have a positive slope. All right, and we'll kind of compare these as well. We'll compare these now with a positive compared to a negative slope. The next one here is going to be y-intercept of -7. So now I'm going to go down to -7. You can see the x-coordinate, right, is 0, and that's the y-coordinate. So 1, 2, 3, 4, 5, 6, 7. Now here, you can see that, well, now my slope is a -5, right? So a lot of people are like, oh, crap, like I got to go down 5 and then to the right one. That's going to go really low, right? So remember, -5 over 1 is the same thing as 5 over -1. And maybe if you're a little tricky with that, like think about it this way, -4 over 2 is the same thing as 4 over -2, right? So it doesn't matter where the negative is, if it's in the numerator or in the denominator. So what I'm going to do is I'm going to flip the script here because I don't want to go any further down, right? So I'm going to rewrite this as 5 over -1. So that means between my next point here, here's my y-intercept. To find the next point, I'm going to have a vertical change of +5, so up 1, 2, 3, 4, 5. And a horizontal change of -1. That's going to be going to the left, right? Because again, remember your xy axis, to the right is positive x, to the left is negative, right? For on the y, up is positive, down is negative. So I'm going to go up and to the left, and then I'll just go ahead and connect those points. And voila. All right, now let's go and get into some equations. So really the only difference here when we have an equation is we just need to understand what the m and the b is. So b is basically your constant, right? And m is going to be your coefficient of your linear equation. So again, we have y equals mx plus b. So sometimes when you're first doing this, it's just helpful maybe to write out m is 1 and b is 1, right? Because 1 times x is equal to x. Oops, not 0. My point is, do not do 0 times x. Because 0 times x is 0. It does not equal x, right? So you got to be careful. If there's not a number there, it's the number 1, not the number 0. All right, so, real quick, before I even get to that, do you see as I'm reading this graph now from left to right, the graph is going down? That means the slope is negative, right? That works, and you can see that slope is negative. So as you read it from left to right, you can go up, that's a positive slope. As you read the graph from left to right, you can see it's going down. That's when you have a negative slope. All right, so here's our xy axis. We have +1. And then now, this is kind of weird when you just have a 1. Again, remember slope, we want this to be a fraction, right? So we're going to write this as 1 over 1. So I'm going to go up 1 over 1. And again, you could also go down 1 to the left 1, right? Doesn't matter if you're going to that positive and positive or negative and negative. Therefore, I can just go and graph this. And there you go. Now, in the next example, y equals 2/3 x plus 4. You can see I have my y-axis. Now, this one's nice because we have a fraction for our slope, so we know we're going to have a positive change, vertical change, as well as a positive horizontal change. Or we could do a negative over a negative, right? But 1, 2, 3, 4. The one thing actually I want you to kind of see, though, is 2/3 is less than 1, right? So how is that going to impact the graph is when the slope is a fraction less than 1 compared to actually being 1. So let's look at that. So let's actually go in the negative direction. Let's actually slope. So m is going to be 2/3 and b is going to equal 4. You can see 1, 2, 3, 4. You see I have my slope here. I'm actually going to go though in the negative 2/3 way. So I'm going to go down 3 and then to the left 3. 1, 2, 3. So down 2 to left 3. I should probably go space a little bit farther. But either way, you can kind of get the idea here. Going to the left. And you could have gone obviously to the right here. 1, 2, 3. Up 2 to the right 3. You can see how it works that way as well, right? These are what we call those slope triangles. You could go +2, 3, or you could do -2, 3. So -2, -3. It doesn't matter which one you go. Now, the one thing actually I wanted to bring up with this though, real quick, before we finish off the rest of these, is notice how this one's not as steep, right? You have one here, that's kind of like that nice perfect slant. when you had your slope that was larger than 1, that made the slope more steep. Like it rose faster. Whereas when your slope was a fraction, like less than 1, then it climbed a little bit slower. And then obviously when it's negative, it actually starts going down. All right. So now let's just kind of work into a couple of different examples here. Again, in this case, we have negative b. So again, we can rewrite this as y equals a negative x plus a negative 3, right? We can always do a subtraction problem as plus a negative. So in this case, my b is equal to a negative 3. And your m could be a negative 1 over 1, or it could be a 1 over negative 1. It doesn't really matter which one you want negative, either the rise over the run or the run over the rise. Doesn't really matter. So let's go down to negative 3. 1, 2, 3. I'm going to do up 1 to the left 1. Again, guys, all you need is 1 point, right? Or 2 points, I'm sorry. Once you get your y-intercept, you only need 1 point. All right, the next one is we're going to have some fractions here. So that's perfectly fine. So again, we're going to do negative 1/2. So in this case, my m is equal to a negative 1/3. And my y-intercept, my b, is going to equal a negative 1/2. Now, I don't know why I would do a problem like this. This is not going to be fun. I'm just going to be sketching the graph here. So I'm just going to do a rough sketch here. All right, so my y-intercept, if here's 1 and here's 2, so my y-intercept's down at negative 1. Now, again, if I'm at negative 1/2, right, and here's positive 1/2. If I'm at negative 1/2, if I'm going to add a positive 1, then that's going to take me up to positive 1/2, right? So if I'm at negative 1/2 and I'm going up 1, right, that's going to take me to a positive 1/2. And then you can say, now I'm going to go over 3. But actually, I'm not going to go over 3. We actually need to look at this a different way, actually. Because I could do this as a negative 1 over 3, or I could do this as a 1 over negative 3. And I'm actually going to do it this way. I'm going to go down 1. So if I'm at negative 1/2, if I go down 1, that's going to be negative 3/2, right? And you can see like that's a distance of like 1 unit. And then I'm just going to go to the right 3. 1, 2, 3. So even though it looks like a difficult problem, it's actually not that bad, because if you had negative 1/2, you add 1, you subtract 1 to it, you're just going down 1 more unit. You can see how that kind of works and makes sense. All right, the next one here, again, we have another whole number negative. So just remember that can be rewritten like this. So we could write that as y equals a negative 2 over 1x plus 1. Or we could write that as a y equals a 2 over negative 1x plus 1. So let's go and graph this as a y-intercept. Remember, b is equal to 1. So my m is equal to negative 2. So b is 1, so that's going to be my y-intercept. And then let's actually, I don't know, let's go up and to the left. So let's go up 2 and to the left 1. So up 2 to the left 1. Okay, and then let's go down 2. Let's just do both of them to the right 1. And sometimes when you're graphing, it is just helpful to kind of get a better idea of those points of the graph just by going to the left and to the right. All right, so now we're going to get into a problem that gets a little more fun here, where we have y equals 7x. Now, again, you recognize this and you say, well, there's no b, right? So remember, slope-intercept is y equals mx plus b. So what can I add to 7x where it actually would not like be there? Well, that's going to be 0, right? So in this case, we can say m is going to equal 7 and b is going to equal 0. So that means the y-intercept is going to cross here at my origin. And then I'm just going to follow my slope, which I can rewrite as 7 over 1. So 1, 2, 3, 4, 5, 6, 7 over 1. And you can see that is a very steep slope, right? Climbing up 7 and only over 1, right? A lot different than when we had a fraction less than 1, right? You can see that's a much slower. So those fractions is reducing that slope, how fast it's going to climb. All right, number 6 is, again, just another one. We can write that as 6 over 1. So my m is equal to 6, and my y-intercept, which is my b, is going to be 0, negative 3, right? You could also say b equals negative 3. It's the same thing. So this one, we're going to go down to negative 3. 1, 2, 3. And then go up 6 over 1. So here's my y-intercept, go up 6, 1, 2, 3, 4, 5, 6, and then over 1. There you go. All right, so the next two problems get a little difficult because most students at this point, they're like, all right, I'm kind of getting an idea of this, but now what do I do here when I have y equals a -4? So this one's not as bad, but we can look at just because we can look at it in terms of slope-intercept form. So if I was going to look at this in terms of slope-intercept form, you know, again, just kind of like what I did in this previous example, I can put b as 0. And if I was going to take this equation and I was going to take, if I was going to take my m to be 0, then you can see that's just going to be y equals b. So whenever you have y equal to a number, you're just going to have it equal to that y-intercept. Now, therefore, we can see that here's our graph. We're going to have -4. So 1, 2, 3, 4. Now, what does the graph go ahead and look like, though? That's a lot of times people are like, what is, you know, we don't have a slope, right? 0 over 1, like, how is this going to work? So the best way I like to look at this is kind of this example, look at the table. So if I was going to create a table here, and remember when we first learned to graph, we learned to use a table of values, or at least hopefully you did. So if I take this and I say, all right, let's just go and pick some numbers for x and let's plot the y values, right? Because again, remember, a graph is made up of infinite many points. So I can always take an x value and I can find the y value, right? And typically what we did is we would take the value x, plug it into the equation for x, and then find the y. Well, this problem's kind of interesting because there's nothing to plug in for x. So if I say, what is x of -2? Y is equal to -4. When I say x is equal to 0, you say y is equal to -4. When I say x is equal to 1, y is equal to -4. When x is equal to 3, y is equal to -4. Y is always equal to -4. It doesn't matter what I plug in for x. It doesn't matter what x value I choose. It's always going to be equal to -4. So you can see what this is this is just going to be a horizontal line. So using this understanding is going to help us with this one because here we don't even have this in slope-intercept form. We can't even write this in slope-intercept form, right? This y equals mx plus b, like this one doesn't make any sense as far as how we're going to have a slope and a y-intercept. However, if we kind of use the graphing game, now again, like here we have x and y. Now again, x is equal to 1. Well, what about when y is -2? Doesn't matter, x is 1. What about when y is 0? Doesn't matter, x is 1. What about when y is 1? Doesn't matter, x is 1. What about when y is 3? X is 1. So x is always just equal to 1. It doesn't matter what the y coordinate is. So that graph, if I have different y values, you know, for -2, x is equal to 1. When y is 0, x is equal to 1. When y is 1, x is equal to 1. When y is 3, 1, 2, 3, x is 1. And you can see here, this is a vertical line. And when you have a vertical line, since we are now, we don't have any horizontal slope here, right? You can see the slope is always increasing, right? Or decreasing, but there's no horizontal change. So therefore you have a rise over 0, right? There's no horizontal change. So therefore the slope is undefined. That's why we call it an undefined slope. Here, m is just equal to 0, right? Because there's no change vertically. But here, since there's no change horizontally, that means your slope is being divided by 0. Therefore, it's going to be undefined. All right, let's go ahead and wrap these up. Kind of same kind of questions here, guys. We have 4, 1. So there we have my m equals 4 and my b, which is my y-intercept, is equal to 1. So in this case, I'm just going to go up to 1, and then I can go up 4, 1, 2, 3, 4, over 1, or down 4, 1, 2, 3, 4, to left 1. And there you go. In this case here, we can see that I can write this as a 1 over 1 plus 0, right? So m is equal to 1, and b is equal to 0. Now again, that could be 1 over 1 or -1 over -1, right? But this is actually what we'll call the identity element. For every element x, I have a y. Every negative, I have a negative, right? When x is, when x is -1, y is -1. When x is -2, y is -2. So you can see this identity element, whatever x is, y is. Whatever y is, x is. That's why we call this the identity function. But we'll talk about that stuff later. This next one, y equals 5/2 x. Again, we don't have a y-intercept, so that's going to be 0. Now, in this case, we have a slope of 5 to 2. So we're going to rise 5 and have a positive slope of 2. Or we could do a -5 over -2. But I like going positive whenever possible. So just from 0, 0, which is my y-intercept, I'm going to go up 5. 1, 2, 3, 4, 5. To the right 2. Okay, and then I'll just estimate going in the other direction. Here's another example where I'm given my y-intercept, which is 0, -2. So up 2. And then this one is going to be up 3. 1, 2, 3 to the right 2. Right? And again, you could go down 3 to the left 2 if you really wanted to. My graph is looking really bad. Geez, what the heck did I do there? That's 3. 1, 2, 3, 2. So 1, 2, 3. Should probably make my tick mark like that. It's a really bad graph. But that's why typically we like to do this stuff with graph paper. There you go. It's a little bit better. Okay. The next one, y equals 7/3 x plus 11. So again, like here's another example. I can go up to 11, but I don't want to go up another 7 and then over 3. I'm going to go down 7 and to the left 3, right? Because again, 7/3 is equal to a -7 over a -3. But let's do this one here. So I'll go up to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But instead of going up another 7 more and to the right 3, I'm just going to go down 7. 1, 2, 3, 4, 5, 6, 7, and then to the left 3. There you go. Oops, I forgot to go up to 11. There you go. And now we can just sketch our graph from there. All right, next one is y-intercept of -1. And then up 1 over 2. There you go. Y-intercept 0, 5. So 1, 2, 3, 4, 5. And again, slope is 0, so therefore there's no change. There's no vertical change, right? So at 0, 5, we can write it like that. And so that'd be y equals 5. You know what? Let's rewrite these actually in slope-intercept form. -1. I don't know why I didn't do that before. I'll go back to those ones in the front. All right, last two guys. We have this one is going to be m is equal to 2/3. B is equal to 3. So again, this one I'm going to go up to 3. 1, 2, 3. And then go up 2. And then to the right 3. 1, 2, 3. There you go. And then last one, this one kind of looks a little tricky, right? And just remember though, we can rewrite this as a 1/2 x plus 3, okay? So now my y-intercept is still going to be 3. 1, 2, 3. And this one, I'll go down 1 to the left 2. So down 1 to the left 2. And then you can go and graph, okay? So there you go, ladies and gentlemen. That is basically how you go ahead and graph a line in slope-intercept form. Again, just to review, we want to find these. We want to go ahead and find the y-intercept as well as the slope in y equals mx plus b. And remember where the slope, which is your m, is going to be the rise over the run, or the change in the graph from one point to another point. And if that slope is positive, as you read the graph from left to right, it's going to rise. If the slope is negative, as you read from left to right, that graph is going to be falling down. The larger that number, the faster the graph is going to climb. The smaller that number, between 0 and 1, is a fraction. That's the slower the graph is going to climb. Just remember when you have a, if it's a horizontal line, that's going to be y equals whatever that value. And if you have a vertical, where the slope is 0, and if you have a vertical line, that's going to be x equals a value where you're going to have a undefined slope. So let me just write these real quick. So that's going to be a 3x plus 2. And this one would be a y equals a -5x minus 7. Boom. Okay, so there you go, ladies and gentlemen. Hopefully that was helpful, and I look forward to seeing you guys on the next video. Cheers.